In this video, we are going to go over continuous central measures and dispersion. So, how do we find measures of central tendency if we have continuous data? Remember, continuous is measurements. So how that is different is since we don't know the exact values, they put it within an inequality. So how do we find the mean if we have a range and we know how many are within that range? We use the mid-interval as our given x value. So the mid-interval is just your lower bound of that inequality plus the upper bound divided by 2. So you find the mid-interval of each group. That's what you're putting in as your x values in L1. Frequencies go in L2, and then run your 1-bar stat like usual. Median, same thing. 1-bar stat, doing it by hand is a pain. Scroll down to the median, and then modal or mode is the group with the largest frequency. So 5-number summary, other parts of tendency and dispersion, minimum, smallest data value. Q1 is your data value at the 25th percentile, aka the median of the lower half of your data. Median, we've already talked about, it is the value at the 50th percentile or that middle in the group. Q3 is the data value at the 75th percentile, aka the median of the upper half of your data value. And then max is your largest data value. All of these can be found by running your 1-bar stat, so you don't have to do them by hand. It is at the very end of that grouping, so you'll have to scroll down, but it lays it out in the exact same order here. So on this example, we want to find the estimate mean, median, and mode. If you notice, this is continuous data because we're talking about weight. So we know that there are 5 weights between 2 and 3 kilograms, 19 between 3 and 4, 17 between 4 and 5, so on and so on. So again, we don't know what these actual data values are. We just know how many are within each range. So first step, find the mid-interval. As you can see, I've already put it in that column. So how we got that? For that first group, our lower bound is 2, our upper bound is 3. So 2 plus 3 is 5. 5 divided by 2 is 2.5. Do the same thing for every single group. That's how we get our mid-intervals. Those go in L1. Frequency goes in L2. Make sure you link that frequency list in when you do your 1-bar stat, and we get a mean of 4.2. Scroll down, the median, we get 4.5. So our median is going to fall within the weight group of 4 to 5 kilograms. And then again, mode is the group with the largest frequency. So looking at that frequency column, the largest is 19. That goes with the weight group from 3 to 4 kilograms. So that is our mode. Next, measures of dispersion. So the first one is range. It tells us the full spread of the data. That formula is that the range is max minus min. You must subtract that value and write it as a single value. It is not from this value to this value. Subtract every single time. And then again, that formula is not in the folder, so you will have to memorize that one. Standard deviation, it is the average distance your data value is from the mean. There are 2 different symbols. The first one is omega x, that is your population standard deviation. Anytime an IB question asks you for the standard deviation, this is the value in the calculator you must choose every single time. S of x is your sample standard deviation. You would use this if you were gathering data and writing a paper versus answering a question that IB gives you. The interquartile range, IQR, that is the middle 50% of your data, so Q3 minus Q1. And the main thing is you use 1-bar stat to get these values. 1-bar stat will straight up give you both the population and sample standard deviation. They will give you your min, your max. You just personally have to subtract them. They will give you Q3 and Q1, and again, you will have to subtract those to get the IQR. Next, we're talking about outliers. Outliers are values that are significantly larger or smaller than the rest of the data. Now, you can't just say, that value is super far away from the rest of them. It's an outlier. There is a specific requirement. And that test is any data value that falls outside of the boundaries. So to find your boundaries, the lower bound is Q1 minus 1.5 times the IQR, and your upper bound is Q3 plus 1.5 times the IQR. So if there's any values that are less than the lower bound or more than the upper bound, then you can say, yes, we have outliers. Now, the key thing with your outlier boundaries, you need to memorize this because these rules are not in the formula folder. So we have two examples. We want to determine if we have outliers. We're going to start with that second one because if you notice, we've already been working with that and have put that in our calculator. So looking at our calculator's one bar stat, Q1 is 3.5, Q3 is 4.5. So your IQR, 4.5 minus 3.5 is 1. So finding our lower boundary, we have 3.5 minus 1.5 times 1, which is 2. Finding your upper boundary, we have 4.5 plus 1.5 times 1, which is 6. So looking at the lower boundary first, do we have any data values that are less than 2? Well, our lowest boundary is 2, and it is 2 is less than or equal to W. And we have 5 within that group. But we don't have anything smaller than 2. Our lower boundary, you have to be less than that, and we don't. So if we have outliers, it is not on the lower bound. So looking at the upper bound, anything larger than 6 is going to be an outlier. If we look at our table, we have 3 data values between 6 and 7. Now here's the catch with that column. We don't know what those values actually are. So if all 3 of those are 6, they're not outliers. But if they're anything larger than 6, then they are outliers. But we know for sure we have at least one outlier in this group because there is one data value between 7 and 8, and that is above 6. So do we have outliers? Yes, we have at least one, but we could have up to 4. Now for our first set of data, it is just a list of numbers, so we put them in L1, clear out L2 when you run your one bar stat. We get Q1 to be 150, Q3 to be 188.5. Subtract them and we get the IQR of 38.5. So then finding your lower bound, we have 150 minus 1.5 times 38.5. So our lower bound is 92.25. Our upper bound, 188.5 plus 1.5 times 38.5. Our upper bound is 246.25. Now, looking at that lower bound, our data values, none of them are less than 92.25. So if we have outliers, they're not on the low end. Our upper bound is 246.25. Looking at our data, do we have anything larger than that? And the answer is yes, 288 is larger. So we have one outlier.